Welcome back, everyone. This is episode number 5, and this is actually the final episode of our CSCA Physics Preparation Series. We have come a long way together: mechanics, electromagnetics, thermodynamics, optics, and today we are finishing strong with the modern physics. Now, before we begin, I want to tell you something important. This entire series include today videos is a short and focus series. I have only covered the most important topic and key formulas that you need for the CSCA exam. Nothing extra, nothing unnecessary, just what matters. This was designed to save your times during preparation, just like I wished I had when I was preparing. So let's finish this series strong, syllabus first and then straight into the notes. Today we will cover the last topic, which is the modern physics. Uh, Within modern physics, we will cover photoelectric effect, atomic structure, fundamental of nuclear physics. So let's go and cover it from the notes. So this is the section number 5, modern physics, and it is the last section. And today we will cover photoelectric effect. What is the photoelectric effect? First we will study key concepts from photoelectric effect, then we will go further. So photoelectric effect is what is the photoelectric effect? Emission of electron from a metal surface when light of sufficient frequency falls on it. It is the emission of electron from a metal. Okay, so when a light fall on the surface and this light have a sufficient frequency, so it when sufficient frequency light fall on a metal surface, they emit electron, which is with this, and this phenomena is called photoelectric effect. Emitted electron are called photoelectron. So they are called photoelectron. Okay, and only frequency matter in this process. Only frequency matter, not intensity for imaging. Okay, and important observations are, you can say that last is that threshold frequency. What is threshold frequency? It is represented by V naught. Below this frequency, no emission, no matter how intense the light is. This is the frequency. This is the minimum frequency which is required for the emission, and below this frequency, there will be no emission of electron, no matter how intense the light is. Okay, what is the kinetic energy of okay, the kinetic energy of photoelectron depends on frequency, not intensity. This is the important point. They say that the kinetic energy of photoelectron, okay, the photoelectron, the electron which emit which are going to emit from the metal surface so the kinetic energy of that photoelectron depend on frequency. Okay, this is the important point, and MCQs can come from it, and it does not depend on intensity. Okay, number of emitted electron depend on intensity. There is another important point. They say that number of emitted electron only depends on intensity. Okay, this is the important point, and emission is instantaneous. Okay, so the emission process is instantaneous, mean that it take by self. Okay, so now we will come to cover the important formulas, which is Einstein photoelectric equation. Einstein photoelectric equation is that H V is equal to work plus kinetic energy maximum. Here H is Planck constant and V is the mm, uh, V is the frequency. It is here is V represent frequency, and W is the work, and plus Ke is the kinetic energy. W is equal to HV naught. W also we know that W is equal to HV naught, so kinetic energy maximum is equal to HV minus V naught, and kinetic energy maximum is also equal to EV naught. This is the formulas which you remember. Here the H is representing Planck constant, and its value is 6.63 and 10 power minus 34 joule second. You must also memorize it. which is the charge of electron. Charge of electron, we discuss it also before, and here we will discuss it again, that charge of electron is 1.6 and to 10 power minus 19 coulomb. Okay, now we will go to the next subtopic, which is atomic structure. We cover photoelectric effect, and now we will study atomic structure. What is atomic structure? Let's discuss it. Let me first, oh, they are not organizing itself correctly. Now I think you will clear to see it. This is the next topic, as the atomic structure. Atomic structure. In atomic structure we will study the report atomic model. The report atomic model tell us atom has a small dense positively charged nucleus. Atom has a small dense positively charged space, and which is called nucleus. Electron revolve around the nucleus. This is the report atomic model, and this is the postulate of the report atomic model. The important postulate, the first one is that atom has a small dense positively charged space, which is called nucleus, and the next is electron revolve around the nucleus. Limitation of this the report atomic model is that it cannot explain atomic stability, that how atom becomes stable, and the next limitation is that cannot explain line spectra. They also not discuss the line spectra. Okay, and now Bohr. Now we will discuss Bohr atomic model. The postulate of Bohr atomic model is that electrons move in apex circular orbits. They say that electrons move in apex circular orbit. Next postulate is that angular momentum is quantized, which is equal to mvr is equal to nh by 2 pi. Your important formula, this formula are for hydrogen atom. So for radius of nth orbit, Rn is equal to n square a naught. A naught's value is 0.529 angstrom. Okay, here if they give you that an electron, there is an electron which revolve in the second orbit. This the n represent orbit, so find the radius of that. So you can simply put this value here. You will put n 2 and 2 into square, so it is 4, and multiply it with 0.529. They will give the correct answer. Okay, now next is that velocity of electron. So velocity of electron is represented by Vn, and it is calculated by 2.18 into 10 power 6 meter per second divided by n. Now energy of nth orbit is equal to 13.6 or n square ev. Okay, so this is the a formula for calculating the energy of nth orbit. Okay, now we are going to study that energy of emitted photon. So it is equal to delta E is equal to hv. Now spectre series. What is spectre series? Lyman, for Lyman series, Lyman series lie in the ultraviolet region, and for it n1 value is 1, and Balmer series is with lie in the visible region, and for this n1 value is 2, and for the fashion series it lie in the infrared region, and for this the value n1 value is 3. Okay, now we will cover the next subtopic, fundamental of nuclear physics. Okay, okay, this is H, fundamental of nuclear physics. Key terms, and this is that nucleons. Nucleons, what is nucleon? Nucleon is the sum of protons and neutrons. Next is atomic number. Atomic number is represented by Z, and it's is equal to number of proton. What is mass number? Mass number is represented by A, and it's the sum of proton plus neutron. Okay, you must also memorize it. Nuclear radius formula is that R is equal to R naught a 1 over 3, where R naught is a constant and its value is 1.3 picometer. was next is a mass defect. Mass defect formula is that it is represented by delta m and it's equal to zmp plus zmn and minus m nucleus. Okay, this is the formula for calculating mass defects. Now we will next is binding energy is equal to mass defect and to c square, higher binding energy per nucleus and more stable nucleus. Okay, this is the important point. Next is radioactive decay law. Radioactive decay law formula is this, and it is equal to n is equal to n naught e minus negative lambda over t. Okay, this is the formula of radioactive decay law. Okay, and the next is half life is represented by t1 over 2, and it is equal to 0.693 divided by lambda. Next is types of radioactive decay. Here we will written decay method and change. So alpha decay, in alpha decay helium nucleus is emitted and changes occur in atomic number, no, sorry, in mass number. There will be changes by 4, and atomic number there will be changes by 2, and beta decay there emitted electron is emitted, and here the atomic number is either increase or decrease by 1. And next is gamma decay, and it emit photon and there is no change in the mass number and atomic number. Next is nuclear reaction. Nuclear reaction are two type. One is fission and the next is fusion. Fission is the fission occur when heavy nucleus splits, such that uranium 235 when it splits, then this phenomenon is called fission. And the next is fusion, when light nuclei combine and they form a heavy nuclei. This phenomenon is called fusion, and sun energy is its example. And that that is modern physics done. And with that, our complete CSCA physics preparation series is now finished. We covered mechanics, electromagnetics, thermodynamics, optics, and modern physics, all pipe topics, short, focused, and straight to the point. But I want to ask you something, and I want your honest reply and and the comments. This series was short and exam focused, only important topics and key formulas. But I know that many of you want to go deeper, and you may want a complete and detailed explanation of every topic with full concept and solved example and everything explained from scratch. So if you want me to bring a complete detailed physics series where I explain everything as a full depth, comment down below and let me know. If I get a good response, I will start that series very soon. Thank you so much to everyone who watched this series from episode number 1 to episode number 5. Your support means a lot. Keep preparing hard. You can do this. Subscribe if you have not already. And I will see you in the next series. Good luck for your CSCA exam.